Question 21. Two inductors with the details given below are wound separately on two identical ring type ferromagnetic cores. Okay. Number of turns, gauge of wire, self-inductance for coil 1 and coil 2 are given. The ratio L2 by L1 is. So we have a ring type ferromagnetic core. There are two inductors, right? Okay. And for the first inductor, we have n number of turns, gauge of wire is G, and inductance is L1. Coil 2, there are 2 turns, gauge of wire is G over 2 and inductance is L2. Okay, and we want L2 over L1, right? So the inductance of a ring type, toroidal inductor is mu naught constant n square, which is square of number of turns in the coil, times h. H is, if we take any cross section, what is the height of that? And if A is the inner radius and B is the outer radius, ln of B over A. Okay, so this is the inductance of a toroid. Okay, and given this, we notice this is proportional to n square. So in this case, it's 4n square. And this is proportional to n square. And should gauge of wire matter? Gauge of wire is diameter of wire. Actually, it doesn't show up in this inductance. Okay, doesn't show up at all. So the ratio of inductance just depends on the number of turns in the coil. Ratio of number of turns in the coil, the square of that. So 4n square by n square, which is 4.